For 2,000 years, humanity's greatest minds believed matter comprised four elements: earth, water, fire, and air. Though incorrect, this theory represented the first serious attempt to unlock the fundamental pattern underlying all material reality. Aristotle refined the four elements into a coherent system. Each had qualities: hot, cold, wet, dry. Combinations produced all matter. It was elegant, logical, and completely untestable. Which is why it lasted for 2,000 years. Democritus of Abdera imagined something radical: all matter composed of indivisible particles separated by empty space. He called them atomos, the uncuttable. Without evidence, he was remarkably right. 20 centuries would pass before science could finally prove his visionary claim. Democritus could not prove atoms existed. Neither could Epicurus, who developed his ideas further. The atomic theory was philosophical, not experimental. Without instruments to detect particles, it remained speculation. Brilliant, but powerless. Aristotle's four elements dominated for 2 millennia because they fit observation. Iron sinks, it's earthy. Oil floats, it's airy. Fire rises. Water flows. The theory seemed to explain everything. It explained nothing. Robert Boyle changed everything in 1661. He defined an element as any substance that cannot be broken down into simpler components. Suddenly chemistry had a testable definition. The four-element system collapsed within a generation. John Dalton provided the mathematical foundation. In 1803 he proposed that each element consists of identical atoms with a characteristic weight. Different elements, different atoms. Compounds were atoms combining in fixed ratios. Chemistry became quantitative. Dalton's atomic theory explained everything chemists had observed: why reactions happened in fixed proportions, why compounds were consistent. He couldn't see atoms. He inferred them from patterns in data. That is what science actually is. But atoms were not indivisible. J. Thomson's 1897 cathode ray experiments revealed particles much smaller than atoms, electrons, with negative charge. Atoms had inner structure. Democritus was right that atoms existed. Wrong that they were fundamental. Ernest Rutherford fired particles at gold foil expecting them to pass straight through. Most did. But some bounced backward. He described it as firing artillery shells at tissue paper and having them bounce back. The atomic nucleus had been discovered. Niels Bohr added quantum rules. Electrons occupied fixed orbits at specific energy levels. They could jump between orbits, emitting or absorbing light of precise wavelengths. Every element's unique spectrum was explained. The atom had become a machine. Today we know atoms are mostly empty space, with a tiny dense nucleus surrounded by an electron cloud. Protons and neutrons are themselves made of quarks. The search for the fundamental has not ended, it has only gone deeper. From four elements sketched by Greek philosophers, to Dalton's measurable atoms, to Thomson's electron, to Rutherford's nuclear model, to quantum mechanics, to the quark model. 2,500 years of one question: what is matter made of? I am Takku. Everything you see, taste, and breathe is built from invisible atoms in constant motion. Subscribe to Wisdom of Takku, because the smallest building blocks explain the largest world.